Hello everyone, my name is Titano and today we are going to do the problem of the week. So today we are going to do with a little bit geometry, okay? We are going to draw a bit. So what is the question? A unit circle is inscribed within a regular hexagon. Find the difference between the area of the circle and the area of the irregular hexagon. Just ignore the grammatical error here. And you have the second question. What if the regular hexagon is circumscribed instead? Meaning that the first question is where the unit circle is inside the regular hexagon. The second question is when the hexagon is inside the circle instead. Okay? So first of all, let us consider what is the area of the circle and what is the area of the hexagon. So the area of a circle is pi r squared. And an area of a hexagon. So what do you do? How do you want to calculate the area of the hexagon? So let us consider drawing the hexagon itself. Okay, since this is a regular hexagon, it consists of six identical equilateral triangle with side lengths of the same. Okay, so let's say we have a side length of S here. Okay, the side length is basically the radius of the hexagon, and we also have the aposem. The aposem is basically the distance between the center of the hexagon to the line of the side of the hexagon, not the point, the side, the vertical line from the center to the side of the hexagon. So what is the formula? From here, we can notice that it is equivalent to the area of the six smaller triangles. We have 6 times 1 over 2 AS. A is the vertical length and S is the side length. So we have 3AS. How to express A and S to each other? Okay, so let us take a look. If you notice, the side length of the equilateral triangle of the hexagon, the equilateral triangle inside the hexagon, you can slice it in half and we have the vertical length to be A and the side length to be half, so S over 2. Okay, and we have the radius of R here, but we don't care about this. Notice that the angle here, this angle here is 60 degrees. This angle here is 30 degrees. So let us consider this 60 degrees. So the tangent of 60 is equivalent to what? So tangent is TOA, opposite over adjacent, which is A over S over 2. So we get 2A over S from here. And what is tangent 60? Tangent 60 is basically 1 over square root of 3. Okay. So we have 2A over S equals to 1 over sec 3. So just to make it even easier, so we have S equals to 2A times square root of 3. So let us just rewrite this. 2 square root of 3 times A. So this is the relation between S and A. Okay? Since we have this, so what do we do? What do we do? Let us express this area of hexagon in terms of A and then in terms of S. Why? Because we are good. These two questions will have us deal with the side length first and then the aposem. So the area of hexagon in terms of the side length, so we have 3AS. So from here we can divide it into 2. Since S is equivalent to 2 times square root of 3 of a. So this becomes what? 6 square root of 3 times a. This also means that we can also express it in terms of s. So we change it to a equals to, what do we have? Square root of 3. No. S over 2 square root of 3, in which when we rationalize, we have square root of 3 over 2s. So we times it back in our original equation, the area of the hexagon, and we have it is equivalent to 3 square root of 3 times over 2 times with s. So we have our formula in terms of the apothem and in terms of the side length. So now let us return to the question. So how are we going to solve this? So first, we know that the area of the circle is pi r squared, and it is a unit circle. So the area of the circle is pi times 1 squared, which is pi. Now let us take a look at the first question, where the circle is inscribed inside the hexagon. So first question. So we make a circle. We just draw the hexagon. Just imagine the circle is touching the hexagon. I really hope, I cannot. It's okay lah. Okay. So let's just make it easier for you to see. So let us touch this, touch this, touch this, touch this, touch this, touch this. Okay. Just ignore my horrible drawing. So when we want to observe this diagram, when we break it up into 3 smaller identical equilateral triangles, we notice that the radius of the circle is basically the apothem. So a equals to 1. Here, a is equals to 1. So the area of the hexagon that we have is equivalent to 6 square of 3 units squared. So from here we have the area of the circle the area of the hexagon minus the area of the circle. So let's say the difference d is 6 square of 3 minus pi. That's the area that we have. Now, how about the second one, where the hexagon is inscribed instead? It's inside the circle instead. So what do we have? The radius of the circle is basically the diagonal of the the radius of the circle is basically the radius of the hexagon. Since our hexagon is the same as our circle, this is also equals to the s of the hexagon as well. So from here, we have our formula here. So area of the hexagon is equivalent to 3 square root of 3 over 2. And what is the difference? D equals pi minus 3 square root of 3 over 2. So this is the answer for both of the question that we have. So this one and this one. Okay. Did you get the answer? If you like to see more of this video, if you like this video so much, don't forget to like, comment how you solve this question, or comment your thoughts about this question, and subscribe, and don't forget to ring the notification bell so that you can get weekly updates on what problem I'm going to solve in the future. With that, I'll see you in the next video. Titano out. Bye bye.